Hey guys, how you all doing? It's Lajo here again, back with another video from Biogem at GCSE Chem, and today we're going to be doing C3.11, which is all about nanoparticles, so which is called nanoparticles. And today I'm back in my room, not in the living room or the lounge. So don't want to disturb the family and stuff, so I'm just back here again. And I like filming here as well. I like recording videos here as well. And just before we start again, tomorrow's A-level results day, so good luck to anyone receiving their results. Hopefully it all goes well. And so today we're doing a triple science topic actually. So it's not in combined science. It's C3.11. It's nanoparticles. And I haven't been able to put the links to my website from sections C3.2 to C3.10. So after I do C3.11, I'll try and do all of them, put all of them by today. Or if not very soon, but I'll try and put them all by today. And good luck for anyone obviously receiving their results tomorrow, but for A-level. But just try and forget about it before the day. Enjoy yourselves in the evening, like tonight. Just enjoy yourselves and forget about it basically. And let's begin. So let's begin. If you're following the student book, it's pages 56 to 57 that you want to be looking at. So nanoscience deals with particles which measure between 1 and 100 nanometers, and they are just a few hundred atoms in size. So that just basically means that nanoparticles, they're very, very small particles, and that's what nanoscience deals with. It deals with particles that measure between 1 and 100 nanometers, and these are basically just a few hundred atoms in size, and these are what we call nanoparticles. And these particles can be nanoparticles. Or nanoscience basically, particles. Nanoscience can be described as any particles which are between 1 and 100 nanometers. And so 1 nanometer is 1 times 10 to the minus 9 meters, or 0.000000001 meters. So that takes a long time to write. Just write it in standard form. It's much easier. 1 times 10 to the minus 9 meters is 1 nanometer, and it can also be described as 1 nanometer can be described as a billionth of a meter. And so therefore, in the same way, if 1 nanometer is 1 times 10 to the minus 9 meters, then 1 meter is 1 times 10 to the 9 meters. So 1 times 10 to the 9 meters. No, wait, let me say that again. I think I got confused before as well, in the previous section as well. 1 nanometer is 1 times 10 to the minus 9 meters, and 1 meter is 1 times 10 to the 9 nanometers. So hopefully that makes sense. And then here they ask a question. Sorry if you can hear any background noise, by the way. But what is a nanoparticle? Here they ask a question. Nanoparticle is basically a particle, very small particles. Nanoparticles are very small particles which range between 1 and 100 nanometers, and they're basically really, really small in size. So hopefully that makes sense. That's basically the essence of what the answer. That's basically what they want if they ask what is the definition of a nanoparticle. So it's a very small particle that are a few nanometers in size, or you could say between 1 and 100 nanometers. Or you could say they are made of a few hundred atoms. So hopefully that makes sense. Now, scientists who refer to particles in air, by the way, nanometers is written in the short form. You just write nm, so small n and small m together here. So for nanometers, scientists refer to particles in air, for example, pollutants, pollen, or dust, as particulate matter, and you write it as PM, so capital PM, like we use PM for Prime Minister, where we have PM as capitals. Here we use particulate matter. For particulate matter, we use PM in capitals as well, and they've written that in capitals here as well. So the differently sized particles have different names depending on the size of the particles. Depending on the size, particles can be called nanoparticles, fine particles, and coarse particles. So they're the 3 types of particles that you look at really when you're discussing nanoscience in GCSE chemistry. It's you look at nanoparticles, fine particles, or coarse particles. And coarse particles, you spell coarse as in COARSE and not COURSE. Just want to make that clear. So COARSE for coarse particles, That's how you spell it. And then as fine and basically as fine and coarse particles are bigger than nanoparticles. So we're looking at nanoparticles, we're looking at fine particles, and we're looking at coarse particles. So basically, as fine and coarse particles are bigger than nanoparticles, scientists also use micrometers. And it basically has this, it has basically this symbol, it has basically a U. Ignore what I was doing. That was my A-level chemistry work. But this symbol, hopefully you can see it. Mu and then M like that. Basically, yeah. Ignore the rest of this. This was just A-level chemistry. That was doing some A-level chemistry. But that's mu. That's basically an M. Like that's how you put it. Basically, that's how you draw the symbol for micrometers. Basically, yeah. So as fine and coarse particles are bigger than nanoparticles, scientists use micrometers. And here 1 micrometer is 1 times 10 to the minus 6 meters, and therefore 1 meter is 1 times 10 to the 6 So 1 micrometer is 1 times 10 to the minus 6 meters, and then 1 meter is 1 times 10 to the 6 micrometers. So hopefully that makes sense. Yep, and that's what I have to say. And so you need to know these conversions basically. So I'll go through them again quickly. 1 nanometer is 1 times 10 to the minus 9 meters. Therefore 1 meter is, sorry if you can hear the noise. Therefore 1 meter is 1 times 10 to the 9 nanometers. And then 1 micrometer is 1 times 10 to the minus 6 meters. And then 1 meter is 1 times 10 to the 6 micrometers. So hopefully that makes sense. Nanoparticles have diameters between 1 nanometer and basically nanoparticles have diameters between 1 nanometer and 100 nanometers. So basically, 1 nm and 100 nm. Between that is their size for the diameter. So it's the diameter that are between 1 nanometer and 100 nanometers, basically. Yeah, so it's the diameter that's between the 1 nanometer and the 100 nanometers. Just want to reinforce that. Which is also known as 1 times 10 to the minus 9 meters to 1 times 10 to the minus 7 meters. So again, because it's 100, that's the range of it. Fine particles, which are known as PM25, so capital PM and then subscript 25. You need to know that. Have a diameter of between 0.1 micrometers, which are obviously 1 times 10 to the minus 7 meters, or 100 nanometers, and 2.5 micrometers, which is 2.5 times 10 to the minus 6 meters, or 2,500 nanometers. So I'm sure this might be a bit confusing, but just read maybe the textbook or something. You need to memorize this. Literally, I can't do anything about this. You just need to memorize the sizes. They could ask this in the exam. Definitely. And coarse particles, which is PM10, so you have PM capital with the subscript 10, is have diameters between diameter of between 2.5 micrometers, which is 2.5 times 10 to the minus 6 meters, or 2,500 nanometers, and 10 micrometers, which is 1 times 10 to the minus 5 meters. So I'm really I'm sure this is a bit confusing, but I can't really do much with this. You just need to learn it. Like even I found this very hard. Being having to remember all these value stuff. Like you just need to remember it just in case they ask in the exam. It's likely to only be a 1 marker, but you don't want to lose kind of marks because you couldn't be bothered to actually remember something. Like that will be, I think, one of the worst ways to lose marks. If you have a question on this, all you need to do is basically remember it and write it down in the exam. So I can't really explain it much because it's literally just numbers. You need to know them. And now, coarse particles are often called dust, and I think that's a useful thing to remember as well. We call coarse particles, often we call them dust. And nanoparticles can be 100 times smaller, even than the finest dust. Because obviously we know nanoparticles are much smaller than, they're smaller than fine particles and coarse particles. So nanoparticles are so small that they can be even, they can be 100 times smaller, even they can be 100 times smaller than even the finest dust. Finest dust will be really, really small. Nanometers like 100 times smaller than that. So it just shows you how small they, just reinforces how small they are. And again, I'll show you this, but I'm pretty sure this just shows the different kind of particles there, nanoparticles, coarse particles, and whatnot. Hopefully you can have a quick look there. I'm not going to really go through it. You just need to learn the sizes of nanoparticles, coarse particles, and fine particles. Like they're just things you need to learn. I think the subscripts will also be, the notation would be good as well, to learn, for all of them. Like I said, PM10, PM25. PM25 is for the fine particles, and it wasn't. Was it? Sorry, it wasn't PM25, it was PM2.5. Yeah, sorry, PM2.5 for fine particles and PM10 for coarse particles. I'm really sorry, that was my mistake. Yeah, it's PM2.5 for fine particles and PM10 for coarse particles. I couldn't see the decimal point there. It was really, really small, that's why. So what I showed you just now was just the size of different types of particles. Like, I'm not going to go through that. It's again something you just need to know, really. I can't really help in this. And also in the student book, it talks about surface area to volume ratio, which is not covered in this section, but you do need to know about that, which I won't be covering because I think it's relatively easy. If you just have a look at the example that's on. I think it's on page 57. But basically, if you're on pages 56 to 57, which is basically what the length of the pages that this section spans, basically on the textbook, basically the pages that this section is about on the red textbook and the textbook. Then if you look at the student book, basically pages 56 to 57, I think it's on page 57, it talks about surface area to volume ratio, and I think it's quite self-explanatory, so I don't need to go over it. So a nanoparticle, here's a second question. A nanoparticle, so we actually have two questions in a row, so we'll go through them. A nanoparticle is 0.000 a nanoparticle is 0.000000005 meters in size. Write that in standard form. So if I just basically, you should know how to do standard form, especially if you do GCSE maths. It's pretty much compulsory. I don't know if they do it in foundation tier, but basically, to convert in standard form, you basically, if it's 0.000000005, you basically you count it up. You keep going. You move the decimal point until you get to 5, and you see how many times you move it. And if you're moving it right, it would have a negative power. If you're moving it left, it would have a positive power. So here, if it's 0.000000005, well, that will be 9 times you're moving it to the right. So it'd be 5 times 10 to the minus 9. It'd be 5 times 10 to the minus 9 meters, because you're moving it right. Moving the decimal point right 9 times, basically to the right 9 times, and because basically in standard form you have numbers which are between. You have to have numbers between I think 1 and 9, isn't it? Something like that. I can't believe I do A-level maths and I forgot this, but basically you can check it out yourself on the internet. But standard form's always between the 1 and 9. I'm pretty sure. So let me just check that is right, because I'm pretty sure that is right. Like, I do know how to convert in standard form, but let me just go over it. Let me just see it to make sure I'm not wrong. And it is 5 times 10 to the minus 9 meters. Yes. And then how many nanometers is 0.0000005 or 0.00000? How many nanometers is 0.0000005? Well, that's basically what we've just been through. That's the same number as there was before. Now we need to convert this into nanometers. We've said 1 meter was 1 times 10 to the 9 nanometers. So basically, you'd move it 9 to the right, and you'd get 5 nanometers. So that should be the answer. Yeah, 5 nanometers, 5 nm. You can write nm for short for nanometers. And 2 more points left, and then we're going on to the keywords and key points, and also some study tip. So materials may behave very differently as nanoparticles. Nanoparticles' high surface area to volume ratio makes them much more reactive than normal sized particles. Now they might ask you, why are nanoparticles more reactive? It's because nanoparticles have much larger surface area than normal particles, and so it says here again, this is because the reason why they're more reactive is because they have a higher proportion of their atoms or molecules at the surface of the particle. Basically, they have a very high surface area compared to much higher surface area than normal particles. Yeah, so you need to know that they have a very high surface area, and there are more particles, greater proportion of particles, or atoms, or portion of the atoms or molecules at the surface of the particle, and that's why nanoparticles are more reactive than kind of normal sized particles. You need to know that. And also you need to know that the use of nanoparticles instead of traditional bulk materials should mean that smaller quantities is needed. So they might ask, because basically there are more atoms and molecules of the greater portion of the atoms or molecules of the particles on the surface. That means if we're not using bulky, you're not using nanoparticles for bulky materials, it means that smaller quantities are needed of nanoparticles, which obviously save costs and stuff. You don't need to know about the cost stuff, I'm pretty sure. You do need to know about the applications, which we'll go through in the next section, because it's C3.12 applications of nanoparticles. But yeah, that's basically it, guys. You need to know that as well. And the study tip is write a tweet to explain what a nanoparticle is. You can just write a paragraph to explain what a nanoparticle is. And I think if you write this thing, it would really help you, because then you can really look in the textbook again what thing you've missed. And I haven't talked about how to calculate surface area to volume ratio thing, but actually this is explained in the student book, pages 56 to 57. So do have a look at that. I think there's a whole table on that. It really explains it, but I'm not going to take my time to actually explain it here, because already the video is getting too long. And so that's the study tip there. That's a study tip. Just write a tweet, or you could say write a paragraph. Basically, write anything that is explain. Write a few lines about what a nanoparticle is. Basically, here it says write a tweet. Like, I don't know. But the key points, just before we finish off, are nanoscience is the study of small particles that are between 1 and 100 nanometers in size. Yep, you need to know that. They are between 1 and 100 nanometers. Their diameter is between 1 and 100 nanometers. I'm pretty sure it's a diameter. Yep, they have diameters between. Yep, that's fine. And then the nanoparticles may have properties from those that are from the same material in bulk. This arises because nanoparticles have a high surface area to volume ratio with a higher percentage of atoms exposed to surface. Basically, you need to know nanoparticles can have a much higher surface area than normal sized particles, and you don't really need to know much about the bulk part. That's just a bit of just extra information. It's not much needed, really. You don't need to worry about that. And then the final thing is nanoparticles may result in smaller quantities of materials such as catalysts being needed for industrial processes. So smaller quantities of materials would be needed because nanoparticles have a very high surface area to volume ratio. They're very reactive. They're much more reactive than normal sized particles. They have a higher surface area than normal sized particles, and therefore smaller quantities of materials such as catalysts being needed for industrial processes. So you might not need as many catalysts. So you might not need as many quantities of quantities of materials. Now that's the benefits of actually nanoparticles, and we're going to look at the disadvantages of nanoparticles later on in the next section. As I said, C3.12 applications of nanoparticles, and we're going to look through all of that in the next section. So this is the end of the section, guys. I really hope you find this video helpful. Make sure to share, like, and subscribe, and turn the notifications on, turn the notification bell on if you haven't already, so you're notified and updated when I upload new videos that you can watch. And I'll try and put the links to all the C3.11 today. And good luck to anyone who has A-level results day tomorrow, and I'll see you for the next section tomorrow. Thank you very much, guys.